Good day, class, and welcome to today's class. So last week we talked about study section 1 and all the units in study section 1. Now today we'll be going to study section 2. What are the objectives in study section 2 unit 1? The objective of this study session is to equip students with a solid understanding of statistical measures of location, partition, and dispersion. By the end of the session, students will be able to define and calculate key measures of central tendency, including the arithmetic mean, harmonic mean, geometric mean, median, and mode. Understand the purpose and appropriate application of each measure in analyzing data. Interpret results to make informed conclusion about data distribution and build a foundational skill set for further studies in statistical analysis and interpretation. The learning outcome for study section 2, unit 1, 2, and 3. By the end of this study session, students will be able to 1. Define and explain the key concepts of measures of location, which is our study section 2, unit 1, partition, which is our study section 2, unit 2, and dispersion, which is our study section 2, unit 3, in the context of descriptive statistics. Compute the measure of central tendencies, which include our arithmetic mean, harmonic mean, geometric mean, median, and mode. Interpret and differentiate the measure of central tendency based on their uses, advantages, and limitation in analyzing data sets. Calculate the partition measure such as percentile, decile, quartile to understand data distribution, which they are all in our study section 2, unit 2. Compute measure of dispersion, which include the range, the interquartile, variance, and standard deviation, and explain the significance of dispersion in understanding the spread and variability of data. Apply statistical measure of location, partition, and dispersion to real-life data sets for effective analysis and decision making. The last but not the least is to summarize data using appropriate statistical tools and draw conclusions based on the quantitative evidence. Introduction. The measure of location, partition, and dispersion are essential in descriptive statistics as they summarize the characteristics and distribution of data. They help in understanding the central tendency, dividing the data into segments, and quantifying the spread of variability of the data points. Now, in our study material given to us, when we check, we see that study section 2, unit 1 is measure of location. So now we are in study section 2, unit 1. Measure of location. The center of distribution can be calculated using the measure of location. Essentially, they describe the data with single values, and they are also known as the measure of central tendency. What are those statistical tools that we use in measuring location? The first is the mean. Our mean can either be the arithmetic mean, geometric mean, or harmonic mean. We also have the median and the mode. They are those statistical tools that we use in measuring the distribution center. Now let's go to the first one, the mean. The first under mean is the arithmetic mean. The arithmetic mean or average of a set of observations. Please listen very well. The arithmetic mean or average of a set of observations is the sum of observations divided by the number of observations. The arithmetic mean, I will repeat it again. The arithmetic mean of a set of an observation is a set of observation is the sum of observation divided by the number of observations. So the arithmetic mean, or briefly the mean of a set of n number is x1, x2 up to xn is denoted and defined as x bar. When we want to calculate the mean, we use x bar as stated in equation 1. So x bar is what we use to denote mean. X bar equals to x1, which is our set of observation given, x1 plus x2 plus x3 up till the last observation given, say xn all over n. Sorry, in this study material it's supposed to be n, not mu. It's supposed to be n, not mu in equation 1 of study section 2 unit 1. Please take note, it's supposed to be n, not mu. So it will be x1 plus x2 plus x3 up to xn all over n. It's going to be summation I ranges from 1 to n, xi all over n, which is also summation of x all over n. Example: the grade of a student on 6 examinations were 84, 91, 72, 68, 87, and 78. They said find the arithmetic mean of the grades. From here, they said the grade of a student on 6. So our n here will be what? 6. Our n here will be 6. Where? So our set of observation are 84, 91, 72, 68, 87, and 78. So to calculate or to estimate this, we say our x bar equals to summation of x over n, not mu. Please take note. So it will be 84 plus 91 plus 72 plus 68 plus 87 plus 78 all over 6, which is equals to 480 divided by 6. So it will give us 80. It will give us 80. Also, if the number of x1, x2, x3 up to sk occurs in frequency f1, f2, f3 up to fk respectively, the arithmetic mean, we can use the formula in equation 2, study section 2, unit 1, to estimate the arithmetic mean. That means if you are given in form of frequency, please take note, if you are given in form of frequency, maybe they said the set of observation, a particular student wrote this so set of observation with frequency so that is when we use the formula x bar equals to f1 x1, which is in equation 2, plus f2 x2 plus f3 x3 plus up to xn all over. Instead of using the number of observation as stated in equation 1, we now use the sum of all the frequency, which will be f1 plus f2 plus f3 up to fk. So now it will now, as stated in equation 2, it will be summation j equals to 1 to k fj plus xj all over the sum of all the frequency given, which is equals to summation f of x, that is the sum of the observation multiplied by frequency. We sum it all together all over sum of frequency, as we can see in equation 2. So our fi are frequency of each class, our xi are the observation, each observation given, and summation fi xi, they are the sum of the product of frequency and the midpoint or the observation given. Each observation, you take each frequency, multiply it by the corresponding observation, and we sum it together. That's how we get our summation fi xi, or summation f of x. Then summation of f is our total frequency. The difference between equation 1 and equation 2: in equation 1 we use n, and x1, x2, x3 up to xn, we add it together divided by n. But in equation 2, which is even the one of frequency, we multiply each observation given by the frequency, we add it together and we divide it by the sum of frequency. So that is the difference between the two equations. Now, our arithmetic mean can also be in form of the weighted arithmetic mean. Sometimes we associate number of certain weighing factors or weight depending on the significance or importance attached to them. In this case, we are in equation 3 of study section 2 unit 1. The weighted arithmetic mean, the formula for calculating the weighted arithmetic mean is given as stated in equation 3. X bar is equal to W1 X1 plus W2 X2 plus W3 X3 up to WK Xn all over. Please take note here also that it is not F1, F2, F3. There is error in the typing. It's supposed to be W1 since we are considering the weighted arithmetic mean, not that of frequency. It's supposed to be W1. It's supposed to be W1, W2, W3 up till WK. So the formula should be W1 X1 plus W2 X2 plus W3 X3 up till WK XK all over W1 plus W2 plus W3 up till WK. So it will now be sum of, we multiply our weight by our observation, weight 1 plus observation 1, weight 1 times observation 1 plus weight 2 times observation 2 plus weight 3 times observation 3 plus weight n times observation n all over weight 1 plus weight 2 plus weight 3 up to weight k. Please take note in that equation 3. Over is not F1, F2, F3. It's supposed to be W1 plus W2 plus W3 up till WK. So it is, which is equals to summation of, we now sum all our weight 1 times observation 1 plus weight 2. That means we sum them together and we divide it by the sum of the weight, not Fk, which is summation of Wx all over summation of W. So let's consider an example here. So if we look at the example given in the study material, they said if a final examination in a course is weighted 3 times as much as a quiz, and a student has a final examination grade of 85 and quiz grade of 70 and 90, the mean solution is, they said the examination is 3 times as much as the quiz. That means the examination, which is 85, will be times 3 of 85 because it's 3 times as much as the quiz. So that means the quiz will be it will be 1 times 70 plus, please check this place very well, it will be 1 times 70 times 1 or 1 times 70, which is plus 1 times 90 plus 3 times 85, because the examination is 3 times as much as the quiz, all over 1 plus 1 plus 3, which is equals to 415. After 1 times 70, that will be 70 plus 1 times 90, that will be 90 plus 85 times 3, which is 255 all over 5. So it will give us 415 divided by 5. So it will give us 83. Another example, so the weights are 1, 1 and 3, while the observations are 90, 70 and 85. So another example, if they say a student, you can write this down and solve it. A student scored the following marks in 3 subjects with different credit weights. Subject 1, we have mathematics. The score, which is XI, is 90, and the weight, which is WI, is 4. Physics, the score which is xi is 80 and the weight which is wi is 3. English, the score is 70 and the weight is 2. To get this, to calculate the weight, we multiply each score with its associated weight. That is 90 times 4, 80 times 3 and 70 times 2. Then we add, that is our, then we sum it together to give us our summation of wi xi all over our summation of w, which is our weight, which is 4 plus 3 plus 2. That one will give us 9. So our arithmetic weighted mean will now be 90 plus 80 plus 70, which will give us 740, divided by our sum of weight, which is 4 plus 3 plus 2. That will give us 9. That will give us approximately 740 over 9 will give us approximately 82.22. That means the weighted mean score is 82.22. Now, let's go to the arithmetic mean for grouped data. When data are presented in a frequency distribution, all values falling within a given class interval are considered to be coincident with the class mark or midpoint of the interval. Example, the table below shows the distribution of the waiting items for some customer in a petrol station in Abeokuta. We have the waiting time in minutes, which is 1.5 to 1.9 minutes, 2.0 to 2.4 minutes, 2.5 to 2.9 as shown in the table. And we have the number of customers, 3, 10, 18, 10, 7, and 2. They say find the average waiting time of the customer. So the first thing we'll do is we tabulate the value given as we can see in the solution. So they gave us just two rows, the waiting time and the number of customers. Then we are the one to look for the class mark, and when we are looking for class mark of x or the midpoint, you can call it either class mark or the midpoint. That is assuming we are calculating the frequency for grouped data. You know, the first one we did is ungrouped data, that of frequency. Then here this one is for grouped data, if our data is grouped. So to get the class mark or the midpoint, we had 1.5, the waiting time, we add it together and we divide it by 2. That will give us our x, which is our midpoint or class mark or our x. So we do for 2.0 plus 2.4 divided by 2, 2.5 plus 2.9 divided by 2 up till the last observation, the last waiting time given, which is 4.0 plus 4.4 divided by 2, because we are adding two things together. So 1.5 plus 1.9 divided by 2 will give us 1.7. So for the second waiting time, 2.2, the third 2.5, 2.7, the fourth 3.2, 3.7, and 4.2. Then we look for that will be our x. Then we look for our fx. F will be frequency times the midpoint. That means 3 times 1.7. 3 times 1.7 will give us 5.1. 10 times 2.2 will give us 22. You can also press your calculator. So 10 times 2.2 will give us 22. 18 times 2.7 will give us 48.6. 10 times 3.2 will give us 32. Like that, like that. Now, we estimate our mean, which is x bar equals to summation of fx all over summation of f. If we check when we are calculating that of frequency, you will also observe that we use summation of fx all over summation of x, but that one is for ungrouped data. That one is for ungrouped data. Summation of fx all over summation of f. So it will now be, we now add all our fx in the table together, then we divide it by our summation of f. So it will now be 142 over 50, which is equals to 2.84, which is equals to 2.84. So another example which you can practice on your own, maybe whenever you are less busy. Let me read the example so you write it down, you practice it. Just practice, yeah. You don't need to submit this. A survey asks people how many books they read in a month. The data is grouped. Book read, one column, midpoint, another column, then frequency, another column. Book read 0.0 to 2, 3 to 5, 6 to 8, and 9 to 11. Midpoint, we have 1. Here you can see that they've estimated the midpoint 4, 7, and 10. Then the frequency is 5, 8, 12, and 5. We know for the midpoint, they have 0 plus 2 divided by 2, which is 2 over 2, which will give us 1. 3 plus 5 divided by 2, which is 3 plus 5 is 8, divided by 2 will give us 4. Then 6 plus 8 divided by 2, which is 14, divided by 2 will give us 7. So here, the midpoint was given. It has been calculated. So you use the same method we used to estimate the one we did, the group data we did for the one I explained earlier, to solve this. At the end of the day, you will get your at the mean of the book read to be 5.7 if you do it very well. Now, assuming sometimes large values of variables are involved in the calculation of the mean to make our computation easier, we may assume value as the mean if, now from here, S bar is summation of fx all over n. When we take the expectation, is summation f of a plus d over n. Now our x bar is, use this summation f to multiply, to open your bracket, it will be summation of fa over n plus summation of fd over n. When we open our bracket, so our x bar will be a summation of f over n plus summation of fd over n. So our x bar will be a, if you see from here, a plus summation of fd over n. Note that our summation of f over n is the same thing as n. So n over a, n over n will cancel n, it will remain a plus summation of fd over n. If a constant c is used, then we use this formula. This is just like a proving. Please go through it. Now let's go to the harmonic mean. Harmonic mean. The formula for calculating harmonic mean is 1 all over 1 over n times summation of 1 over xj as given in the study material. In practice, it may be easier to remember that our harmonic mean is n all over summation I ranges from 1 to j 1 all over x. So example of harmonic, example under harmonic mean. So we also have harmonic mean, the weighted harmonic mean. If we are to calculate the weighted harmonic mean, it will be, please write down the formula. It will be summation wi over summation wi xi, where our wi is the weight of each value and our xi is our data value, so the observation given. Harmonic mean is most useful. When do we use harmonic mean? Harmonic mean is most useful when averaging rate or ratio, e.g. the speed, the price per unit. Example, let's solve an example. They said the harmonic mean of the numbers 2, 4, and 8 is, now n, what is our n? From the formula, our n is 3, which is 1, 2, 3, number of observation, all over 1 over, from the formula, each sample, each data point or each observation, that will be 1 over 2 plus 1/4 plus 1/8, which is 3 over, when you add all this together, it will give you 7/8. 3 divided by 7/8, it will give us 3.43. Another example, it says if a car travels the same distance at speed 40 km, 60 km and 80 km, which are our x high, what is the harmonic mean of the speed? It will be n all over 1 over n all over 1 sum of 1 all over xi, which is also 3 all over 1 over 40 plus 1 over 60 plus 1 over 80, which will give us 3 over 0.0542. So it should be 55.3505, approximately 55.4. Then example under the weighted harmonic mean. Now, under the weighted harmonic mean, I told you that our harmonic mean can also be in form of normal harmonic mean or the weighted harmonic mean. Under the weighted harmonic mean, let me give you this example. A machine produces items at 3 different rates for different duration. So here our n is, we have the rate 50 and the hours worked, which is our weight is 2. The second one is 60, that is the rate, and our hour worked for is 5. The third one is 100 and the hour worked for is 3. So the weighted harmonic mean will now be summation of wi. Instead of considering n in the normal harmonic, for the weighted we always consider the weight. So over summation of wi all over x. So from here, for the first one, it will now be 2 over 50. Second one will be 5 over 60. That means our weight over rate. And the third one will be 3 over 100. So we sum all these together and we divide it by, we sum all our weights together and we divide it by summation of wi over xi, instead of using n all over summation of 1 all over xi. For the weighted one, we use summation of wi all over summation of wi over xi. So if you compute this at the end of the day, you get 0.1533 for the summation of wi over xi. Then you divide it by the total weight. So it will now be 10 all over 0.1533, which will give you 65.2 items per hour. So let's go to the geometric mean. The geometric mean, the formula we use in geometric mean is geometric mean equals to n square root of x1 w1 raised to power w1 times x2 raised to power w2. That is for the weighted geometric mean. For the normal geometric mean, the geometric mean is root of n, which is the number of observation, x1 x times x2 up till xn, or we can use x1 x2 x3 up to xn into bracket 1 all over n. Instead, we can use either the square root or the one of 1 all over n. So from our notes, we can see geometric mean. They said the rate of inflation in 5 successive years in a country is 5%, 8%, 12%, 25%, and 34%. What is the average rate of inflation per year? What is the average rate of inflation per year? First, the first thing we have to do is we convert percentage to growth factor. Please take note of this. We convert percentage to growth factor. And when we convert percentage to growth factor, we simply add 1 to the percentage in decimal form. 5% is 5 divided by 100, which is 0.05. Then we add 1 to it. That is how we arrive at our 1.05. The second one is 8%, which is 0.08. We add 1 to it. That is how we arrive at our 1.08. Then we do for the third, fourth, like that. So we take the square root. After multiplying them together, it gives us 2.12. From my own calculation, it gave me 2.1155. We take the root, fifth root, which is 1.162, or we can also say 1.05 times 1.08, 1.05 times 1.08. No. All is not from the table, is supposed to be multiply, not plus. Everything is supposed to be multiplication. That is 1.05 times 1.08 times 1.12 times 1.25 times 1.34. It's supposed to be multiplication. After getting everything, then we now say the answer is 2.1155 raised to power 1 over 5. It will give us 1.162. I don't know if you are getting what I'm saying. Another example, you can practice that on your own. Suppose the stock grows by 10% in 1 year, 20% in 2 years, and 30% in 3 years. The growth factors are, they've already given us in form of growth factor, not percentage. So we don't need to add 1 to it. So it will be 1.10, 1.20, and 1.30. The geometric mean growth factor is, so we can calculate that. At the end of the day, we get 1.194. Then we now convert our answer back to percentage. So after calculating and we got 1.194, we take away 1 from it, which will give us 0.194. Then with percentage of 0.194, it should be 19.4%. So whatever answer we get in geometric mean, we convert it back to percentage. Please put it in mind that whatever answer you get in geometric mean, we convert it back to percentage by subtracting 1 from it. Because when we want to convert percentage to growth factor, we simply add 1 to it. So when we want to convert back to percentage, we subtract 1 from it. Now, let's go to weighted geometric mean. Weighted geometric mean. So imagine 3 fertilizers are tested for plant growth and their yield in percentage increase are: fertilizer A, we have growth rate, which they've already converted for us, 1.10, and the weight is 2. B, 1.25, and the weight is 3. And the third one, C, is 1.40, and the weight is 5. They said the weighted geometric mean, we use our formula, which is, I think I've mentioned the formula for weighted geometric, which is x1 raised to power w1, which is observation 1 raised to power weight of observation 1 plus observation 2 times observation 2 raised to power weight of observation 2 times observation 3 raised to power weight of observation 3 up till observation n raised to power weight of observation n, all over into bracket 1 over summation of observation, all over 1 summation of 1 over all the weights. So from here, if we calculate it and we get our answer, our answer should be 1.300. Then when we convert back to percentage, it will be 1.300 minus 1. It will give us 0.3 or 30%. If you don't, when you practice it, you can send it to me on Telegram. Just practice, it's not an assignment. Then I will check and later I can send the solution back to you. Then we have when finding geometric mean with frequency. You know, when we are doing for arithmetic mean, we do for weighted geometric mean, we do for the one of frequency. The same also applies to geometric mean. So for that frequency, you can also solve this example. Value, which is our xi, and the frequency. So for frequency, which is our fi, for frequency you can use the root of summation of fi of x1 raised to f1 x times x2 raised to f2 times x3 raised to f3 títí dé xn raised to fn. So if you are giving this data, value xi is 2, 5 and 10 and frequency is 3, 2 and 1. At the end of the day, you must get, your answer should be around 3.55. You can practice all this and send it to me on either Telegram or WhatsApp, and we can check and I can snap the solution back to you. But at least I have to see some people that practice it to be sure that you get what we are doing. Now let's go to median. The location of median, you can see the symbol for median. The location of median x is x, then we have like something at the top is equal to n plus 1 over 2 items. But if n is even, the median is the average of two middle observations in an ordered list. So if n is odd, it will be n plus 1 over 2. Example, for the set of number 3, 4, 4, 5, 6, 8, 8 and 10 has a median of 6. The set of number, we arrange, the first thing when we are talking about median, we arrange in the ascending order, and that is from the smallest to the biggest. We arrange from the smallest to the biggest. Here now, the first thing we do is we arrange from the smallest to the biggest. If we see here, we say n, how many observations were given? From the example, you have 9 observations. So n plus 1 over 2, that will be 9 plus 1 over 2, which is 10 over 2, which will give us 5. Then you can trace your fifth observation from the set of observation, the observation that fall in the fifth position from the set of observation given after arranging in ascending order. Please have it in your mind that the first thing you do is you arrange in ascending order. That is from the smallest to the biggest. So after arranging in ascending order, then you use the formula n plus 1 over 2. Our n is the total number of observation given, which is 9, plus 1, which is 10 over 2. That will give us 5. Then you check for number that fall in the fifth position. From here we have 3, 4, 4, 5, 6, 8, 8 and 10. From here you can count 1, 2, 3, 4, 5. Then 1, you count forward and like 1, 2, 3, 4, 5. So which number fall in the middle? So the number that is in the fifth position is 6. So case 2, if n is even. If n is even, e.g. if our n is given is 6, it will just be n all over 2. The number of observation, which is 3 over 2. If you are given, if our n is like, maybe we have 6 observation, so it will be n over 2, which is 6 over 2. It will give us 3. So, and we also estimate for n over 2 plus 1. So now, when we get that one, we now add together and we divide by 2. That is how we get our median. Also, we have median for grouped data. That is, all those ones are for ungrouped data. We also have median for grouped data. Median for grouped data. The formula for estimating median for grouped data is Li plus n over 2 minus summation of Fi over F median. Then into all in the bracket C, which is our C is the size of the median class. So from the formula given, Li is the lower class boundary of the median class. N is the number of items in the data. Summation of Fi is the sum of frequency of all classes lower than the median class. Then F median is the frequency of the median class, and C is the size of the median class or the class width. So it's in our study materials. So we have an example. They say the table below shows the height of 70 men randomly selected at Sangota. The height is given as 118 to 126, 127 to 135, 136 to 144, 145 to 153, like that. So they say compute the median. We tabulate, we have our height. Our height we have our frequency. Then for us to estimate our cumulative frequency, the frequency of the first row of observation is 8. We had it. To get the second frequency, cumulative frequency, it should be 8 plus 10, which will give us 18. Then to get the third cumulative frequency, it will be 18, which is our second cumulative frequency, plus the third frequency, which will give us 32. To get the cumulative frequency for the fifth row, it will be 32, which is our cumulative frequency, plus the frequency of the class we are estimating. That will be 32 plus 18. It will give us 50. The next one will be 50 plus 9. That means we are adding the cumulative frequency with the frequency to give us the value of our cumulative frequency for the row we are estimating. That means the cumulative frequency before the class we are estimating. To get the cumulative frequency of a particular class, we add the cumulative frequency before the class plus the frequency of that class that we want to get the cumulative frequency. So all this will give us our CF, which is our cumulative frequency. Now, if we now use the median of a group data, the formula, which is Li. Li is our lower class boundary of the median class. What is the lower class boundary? So we say our n, from the formula, our n, Li, which is the lower class boundary. To get the median, we first say our n divided by 2, which is the number of observation divided by 2. From the example given in the notes, our number of observation is 70. So we say 70 divided by 2 will give us 35. The sum, so our n over 2 is 35. The sum of the first class, first 4 classes, the frequency class and the median class. Then when we put this in our formula, so we identify the median class, which is 70 divided by 2. So the median class is 35. Then the class containing the 35th value, we check for the class containing the 35th value, since the cumulative up to the previous class. So any class, previous class before our median class is our CF previous. Then we divide by the frequency of the median class. So our lower class boundary is 144.5. Our n is 70. Our sum of Fi is 32, and our class width or class size is 9. Then when we put all these things in our formula, at the end of the day, we get 136. So let me give you another example here, which we can also solve together. They say class interval, and we have the frequency. If we have 0 to 10 for median of a group data, 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. And our frequencies are 5, 8, 12, 20, and 5. When we want to solve this, we say our class interval is from 0 to 10, 10 to 20, 20 to 30, 30 to 40, and 40 to 50. Our frequency is 5, 8, 12, 20, and 5. Then to estimate our cumulative frequency, the first one will be the first frequency. To get the cumulative frequency for class interval 10 to 20, it will be 5 plus 8, which is our frequency for cumulative frequency plus of 0 to 10 plus 8, frequency of 10 to 20. That will give us 13. To estimate the cumulative frequency of the class interval 20 to 30, it will be the cumulative frequency of 10 to 20 plus frequency of 20 to 30, which will give us 13 plus 12. That one will give us 25. Then we do for others. Then we now take our sum of frequency. We add all the frequencies together. That one will give us 50. That is our n. That is how we estimate our n. The sum of all the frequency will give us our n. So n all over 2 will give us 50 divided by 2, which will give us 25. Then we identify the median class. The median class contain the 25th value. So where is the range of 25 in our class interval? We can see that is in 20 to 30. 25th value fall between 20 to 30. So since the cumulative, we now find the cumulative up to previous. That means before the median class. That means the class before the median class is A. The cumulative frequency is 13. The class before the median class, we say our median class is between 20 and 30, and the class before is 10 to 20. The cumulative frequency of the class before the median class is 13 and up to this class. So when we do this in our formula, it will be lower class boundary. What is the lower class boundary of the median class? The lower class boundary of the median class, because our median class is 25th value, which fall between 20 to 30. So the lower class boundary of the median class is 20. That is our hairline. Then our n over 2 is 50 divided by 2. Our n over 2 is 25 minus the cumulative frequency of the previous class before the median class. The cumulative frequency is 13 before the median class, all over frequency of the median class. What is the frequency of the median class? The frequency of the median class is 12 times the class width. When we are calculating the class width, from here we have 10 to 20. So the class width will be 20 minus 10, which will give us 10. 30 minus 20 will give us 10. 40 minus 30 will give us 10. 50 minus 30 will give us 10. So the class width is the upper class boundary minus lower class boundary. That is how we estimate the class width. So the difference between them is the class width. So for this example, the difference between the class width is 10. Then when we put all this in our formula, it will give us 20, which is the lower class boundary of the median class, plus n over 2. Our n is 50. That is the sum of the frequency divided by 2. Sum of the frequency over 2, that will be 50 over 2 minus cumulative frequency of previous class before the median class, which is 13, all over frequency of the median class. The frequency of the median class is 12 times class width. What's our class width? Our class width is 10. So it will be 20 plus 25 minus 13 all over 12 times 10. So 20 plus 25 minus 13 will give us 12. 12 over 12 times 10. So 20 plus 12 divided by 12 will give us 1. Then times 10. So it will be 20 plus 10. So our median class will be 30. Then let's go to mode. The mode of a set of a number is the value that occur with the greatest frequency. It is most common value. A distribution is said to be unimodal, bimodal, or multimodal if it has 1, 2, or more modes respectively. So here we have 2, 2, 5, 5 example given in the study material. The mode is 9. That is the number that exists most. From here, 2 exists 2 times, 5 exists 1 time, 7 exists 1 time, then 4, 9, 1, 2, 3, 4. 9 exists 4 times. So 9 is the number that occur most, or the number with the greatest frequency. So from here, 9 is the mode. Calculation of mode from group data. From a group data distribution, the mode can be obtained using this formula. So L mode plus theta 1 plus theta over theta 1 plus theta 2, then the class width. So from here, the lower LMO is the lower class boundary of the modal class. Theta 1 is different between the frequency of the modal class and class before it. Theta 2 is different between the frequency of the modal class and class after it. And weight, W is the class size, or we can say class width. From here, example given in our study material, we have class 11 to 20, 21 to 30, 31 to 40, 41 to 50, 51 to 60, and 61 to 70 with their frequency respectively. The L mode is So if we go through this example, since we said the head mode Elmo is the frequency, is the lower class. From here we can see that the figure that occur most, the frequency of the figure that occur most is 21 to 30. Then if you add 21 to 30 together and we divide it by 2. So when we go through the calculation, I think it is very very easy to understand. So that's how we get our value for the mode. Thank you for listening.